Hey guys, today we'll be solving Leetcode 3459 length of longest V-shaped diagonal segment. So this problem is marked as hard, but it's pretty simple and pretty straightforward. Okay, uh, so let me just quickly go through the problem statement. I'll explain you with an example. Okay, it will be much more better. So here we pick a bright color. Okay, so what we're going to do is we are going to find a diagonal of length, let's just say a line with V shaped. Okay, we are going to find the length of the longest line with V shape. Okay, so yeah, this can be, it can be this also, and it can be this also. So it's just need to have that one turning point anywhere in this grid. Okay, so it states that you are going to start off with your grid element as 1. Okay, so this is the starting point, and you can move in any direction in the diagonal which is diagonal to it, this element. Okay, so you can move in any direction to this and you can continue from there. Okay, so let's just say I move in this direction. So you can only move in the diagonal cells only if it is following a sequence of 2 0 2 0 and so on. Okay, so the next diagonal element to 1 should be starting with 2. Okay, so from there we can take it this to be alternating. Okay, so it is going to start off with 2 start off with 1, and then it is going to alternate between 2 and 0. Okay, so here, so also here we can move in all 4 directions, but the thing is here we just need to make a V shape. Okay, so here it is mentioned that you can make at most 1 turn in clockwise direction. Okay, so for this clockwise direction would be only this, right? So you can only move in this direction, or you can just continue with the existing path. Okay, you cannot move in any other direction other than the one that you are already following. If not, you're just going to make a clockwise turn of 90 degree. Okay, I hope that makes sense. You can only move in the direction in which you are moving, or you can just make a 90-degree turn in the clockwise direction once. Okay, just you can make it once. So let's just say I continue with direction. Okay, so here let me just erase this because I don't have an option to go here. So I can follow this path, or I can just follow this. I can make a turn and follow this path, or I can just continue over here. Again, you can observe I cannot move in this direction because it is 1. It is not following the pattern of 2 0 2 0. Okay, so we also don't have an option to make a turn over here. Okay, so once we come over here, we have 2 options. We can move in this direction, or we can move in this direction. Here we cannot move in this direction because it is out of bounds, and here we can move because it is following our alternate sequence also, and it is 90 direction in clockwise. Okay, so we can continue from here. Once we made the direction, then we only have one option, that we can just go in the direction which we are following. Okay, so I hope the fundamental idea is clear. We'll see the approach. Okay, so let's just take this example only, or we can just create our own example, and I'm not going to go through much detail with the help of the example, but I hope the idea can be clear. Okay, so let me take this and let me take this. I don't think it is going to make any difference because I have some points which I want to get clear with, and we can just go ahead with the code. Okay, so uh, the starting point, it's going to be 1. Okay, so I'm just gonna go through a for loop for I starting between 0 and number of rows, and j till number of columns. Okay, n is number of rows and m is columns. So if grade of I comma j becomes equal to 1, that is when we can move forward. Okay, so we can move forward in this direction, this direction, this direction, or this direction. Okay, so yeah, that is what you are going to do. Okay, so let me just write it down over here, so I can move in this direction, right? So it can be I plus 1 j plus 1, or it can be I plus 1 j minus 1, okay, which is this direction, and it can be this direction, which is I minus 1 and j plus 1. It can also be this direction, which is I minus 1 and j minus 1. Okay, so once we move in this direction, okay, so these are the 4 paths which I can take. Okay, so let me call this path as 1, let me call this path as 2, this 3, this is 4. Okay, so this is our, let me also write it down over here. Okay, so this is our first path, this is our second path, this is our third path, this is our fourth path. Okay, yeah. Okay, so once we get started, we can move in the existing direction, which is path 1. So if we are at path 1, we can make we have 2 options. Okay, we can either continue in the same path, or we can make a 90-degree clockwise turn. Okay, also these are only possible if we are alternating between the sequences. Okay, so if previous was 0, it should be 2, if previous was 2, it should be 0. Okay, so here let me erase this, and we also need previous, right? We also need previous. So these are the option when I am just starting out. Okay, so this is my option 1, this is my option 2, this is my option 3 and 4. Okay, so I need prev, I need I and j, of course, and I need which path I am following. Okay, so also if you carefully read through the problem statement, it clearly mentions you can only make the turn once. Okay, so here I have not made any turns. Okay, I'm just starting out, so I'm just gonna take a value, and I'm gonna indicate if I have already taken a turn or if I have not. Okay, if I have already taken a turn, then I need to continue in the path which I'm following. Okay, if I haven't taken a turn, I again have 2 options, if I want to make a turn or not. Okay, so once you explore these options, okay, we can have another function solve, and it will take ij, it will take grid, it will take path, it will take previous value, it will take let's just call this flag. Okay, so these are the values it's going to take. Of course, if I and j are out of bounds, we can just return 0. Okay, if also if our if our I and j, if the index that we are at it's 1, then we can again return 0. Okay, so coming to the path. Okay, once we are in a path, we have two options. Okay, so we have 4 paths, so we have 4 decisions. We have 4 kind of decisions that we can make, but options we have 2. Okay, that is if we can make a turn or not. Okay, if path equals 1, I'm just gonna here explain it for path 1, and we can look into the details of other paths in the code. Okay, so if we are at path 1, like I said, I have 2 options. Okay, if my flag value is either true or false. Okay, if I have already made a turn or if I haven't made a turn, I have one option of continuing in the same direction. Okay, it's always going to be there. It's going to be there. Okay, so this is our option 1. Okay, so I can solve for the existing path. If path is 1, then we know that. So okay, so this was our path 1, this was our path. Okay, let me write it down. This was our path 1, this was our path 2, this was our path 3, this was our path 4. Okay, these are the paths that I'm talking about. So we are exploring for 1, right? So 1, I can move in the same direction, that is I plus 1, j plus 1. Path I can have as it is, previous value I can give our previous value, and flag. Okay, it's going to remain same. Okay, so coming in this option only, we have another option of making a turn only when if our flag is false. Okay, then we have option to make a turn. Okay, so this is going to be our option 2. I'm going to solve. So counter, I need to make a turn in the clockwise direction 90 degrees. So it is going to be I plus 1 and j minus 1. Okay, so once I make a turn, you can see my path is changing. From I was in path 1, then I switched to path 2. Okay, so this is our path 2. This was a path 1, 2, 2, 3 and 4. Okay, so I switched to path 2. And I can set it to true. So when we further explore the path, we can skip making another turn. Okay, so similarly we can try out for the other paths as well. If we are in path 1, I have already showed you. If we are in part 2, we can do the same checks 3 and 4. Okay, yeah, I hope this was clear, and I'll show you the code which will make things much more clearer. Okay, so let's just quickly go through the code. It's pretty straightforward. So I'm gonna take my answer variable, then I'm going to update this whenever I encounter a 1, and I solve for the paths over here. Okay, so whenever I get a 1, then I have 4 options initially. I can move down the right, down left, up right, up left. So this is our path 1, this is our path 2, this is our path 3, this is our path 4. Okay, so you can see I'm moving in this direction, and this is our path. Okay, and this is our previous value. This is our path, previous, path, previous, path, previous. this is our flag value initially, which is going to be false. Okay, so let's move to the solve function. Okay, so you can see ij grid, I have I have j, I have grid, I have flag, I have path and previous. At any point of time, if my I or j becomes greater than if they go out of bounds, then I'm just going to return 0. Okay, so if any point of time, if my grid so in sequence we need to have 0 or 2 only, right? If any point of time we encounter 1, then I'm going to return 0. Also, if my previous is equals, okay, when my previous is equals to 1, then okay, the rate of 1 equals 0 or 0, return 0. Okay, so this is the initial check that we are doing in the first iteration when we move from 1. Okay, so if my grid is 1 or my grid is 0, then again I'm going to return 0, I think. So then I could have avoided this check, or this check, I think. No. Okay, so this is for any of the iterations. This is just for the first iteration. Okay, I forget sometimes what I do. Okay, so also we are going to make sure if our previous is equals to our current, then it is not following the alternate sequence. So again we are going to return 0. Okay, so once we are in a path, then we just have two options. Okay, initially from 1 we have 4 options, but when we are following one path, then we just have 2 options. Okay, in a path we just have 2 options. Okay, so that's why option 1 and option 2. So here for path 1, this is like the default thing that we are going to do, irrespective of the flag value. That is, if you have made a turn or not. If we are in a path, then we are just going to move in that path. Okay, I plus 1, j plus 1. Okay, this was our first path. I'm just going to move in that path. So our previous will update to the current. My flag will remain flag. Okay, so let me explain this. So if I was moving in this direction, our flag would be false. I haven't made a turn yet. Okay, so this will be our false. So I'm going to give the same value to the next iteration. Okay, so the next iteration will also have 2 options. It can either move or it can go. Okay, otherwise once this flag is true, then we just have one option, that is to continue in the existing path. Okay, so that is here. So if our flag was false, then I'm going to set up our flag to true. Okay, and then I'm going to switch paths. Then I'm going to give our flag true. Then I'm going to update path with the path which I have changed to. So I was in path 1 initially, I switched to 2. Okay, so I've updated my path and I have updated my flag value as well. Okay, yeah, so similar thing we can do for path 2, path 3 and path 4. Okay, so I'm going to return at any point of time if these conditions are passing, then I can just increment the length of our diagonal, then I can return. Okay, So I hope this explanation was clear. And yeah, let me know if you guys have any questions. I'll be happy to help you out. Yeah, thank you.